Okay then, so this is probably one of the final things for vector resolution that you need to be aware of. We'll do some more difficult examples in class, and I might post one or two examples if we find them difficult online from the textbook later on. However, what we're going to look at now is using the same question from the previous video, we're going to work out another unknown. Now first of all, the answer to A, the resultant force here is 11.5 newtons. So if you plumb that into your calculator and got that right, brilliant. Please just make sure that you do or are able to get that number. If you can't get that number, spend some time with your calculator and make sure you can, because that is half the battle with physics, being able to use your calculator properly. You wouldn't believe how many people can't. Right, so we're at a stage where we've got a resultant force. Now, you might ask yourself, well, what is unknown about this that we can actually do many more working on? Well, actually, there's plenty. There's two angles that we assigned letters to before, but we haven't done anything with. So B and C are examples of those. So this angle here and this angle here. Now, we're not generally interested in the angle C up the top there. The reason we're not interested in that, don't know why really, it's just not important. This one is what's important really, because this gives an idea of the resultant direction. Because remember from the first video, we wanted to know what the direction was. So this angle here gives a nice idea of the resultant direction from the horizontal. Now if you're ever writing this in a question paper, you would always state the direction which you're taking the angle from. So when we work out this angle, it will be the angle from the horizontal that the resultant force is acting in. Okay? So, how do we work this out? Well, we have done the cosine rule, so sine rule is what's up next. So here we are, we have A over sine of A equals B over sine of B, which is equal to C over sine of C. Now, nicely there, you can use any sets that you would like to use. It doesn't really matter as long as you have enough terms to use it. Now, we only just now have had enough terms to use this, which is why normally we're looking at this cosine, the sine rule doing after the cosine rule, because we need a few more terms, and the cosine rule allows us to work out a few more things, and the sine rule fills in the gaps. Just depends on the amount of angles and sides you have. Now, as you get more experience of these, you'll get to see, okay, well, I've got two sides and an angle. I can use a cosine rule to work out what the other side is, etc., etc. Okay, so how do we use this? Well, I want to work out what this angle is, because that is a resultant direction. So, where is sine B on this massive equation? Well, it's here. And that's going to be our first port of call. Because we're going to want to work out what B is. Now, what information have we got? Now, have we got C and sine C? Well, we know what C is, but we don't know what sine of C is because we don't know what C is. So, we can't use this one. In fact, I'm going to rub it out just to clear up some space. So we're going to use this relationship here, because if we look very carefully, we've got A, we've got the angle A, because we use that for the cosine rule, and we've got the side B, and we want to work out what sine B is, or B is in this case. Right, okay, so one thing I like to do, just to make your life a little bit easier, you can decide to do a little bit of rearrangement do a little bit of working out before doing rearrangement. So in this case, I'm going to use my calculator, so it's going to take a little bit of time, so I'm going to plumb the numbers in as we go, because I'm going to use my calculator as well, and you can follow along, because this is going to be a bit more of an example. So we're going to plumb some numbers into this. We've got A, we've got sine A, so we've got 11.5 divided by sine of 148. And that will equal B over sine B. So what I'm actually going to do, just to make my life a little bit easier, I'm going to work this bit out into one term at the start. So we've got 11.5 divided by the sine of 148. So that is 21.7. So at this stage, we're not too far off what my final answer is, but there's a few little extra tricks. So how am I going to rearrange this? Well, I'm going to move across this way because I don't need too much more space. So, what we're going to do is we're going to say B over 21.7 is equal to sine B. And therefore, finally, we can use, for those of you who are good at maths, will realise the inverse sine function, which is shift sine on your calculator to get that symbol to come up. That will open a bracket up, and you should be then able to do B, which is 7 over 21.7, which is what we worked out before. So I'm going to plumb that into my calculator now. So shift sine 7 divided by 21.7, and that gives me an angle of 2.64 degrees. Okay, so that angle is a bit small, but it is reasonable, considering I only had, we've got 148 degrees here, so this drawing isn't hugely accurate. What we would be expecting to see is something a bit more like this. Let's draw it again. In which case that angle there would make sense to be about 2 degrees. So yeah, we are expecting that to be about the right answer. I've just drawn my triangle a bit dodgy. Okay, so that gives you a use of the sine rule. Very, very important that you are able to do this algebra. This kind of algebra comes up later on when we do some more vector resolution, even of right angle triangles, working out inverse sine, inverse cosine, inverse tangent even rules to work out angles that are missing when we've got sides. Okay, so we do need to be able to do that. You need to get confident with your trigonometry. So that you can rearrange for anything that's in that SOHCAHTOA, really. So get yourself used to that now, so it's less of a shock. So at this point, you've done all of the vector resolution stuff. There is some harder stuff that you should be having a go at in your own time. You should have a go at multiple vectors, more than 2 vectors, but you can use the same rules. There are some other ways of doing them in terms of resolving into horizontal and vertical vectors, but what I've shown you is, I think, the simplest ways of attacking these questions so far, rather than having to do too much working to work out the final answer. So in your own time, so in your notes, you need to obviously have find yourself examples of these, have a go at them, make notes about this. You should have explanations, definitions, specifically what a vector and scalar quantity is, all of that, and we'll look forward to seeing that in the next lesson. Okay, thank you, bye.